Hello, my name is Nicholas Villar, and in this tutorial we will go through CSWP segment 3 sample exam. So let's begin. We have a PDF document with 10 problems that we should solve in 80 minutes. You probably know that segment 3 is about assemblies. So let's begin with the first question. In the first question, we should make a new part called the base part, and we have some dimensions here, and we should find the mass of the part. And please pay attention to this. You have to make sure that you work in a right unit system. So let's start. Open a new part document, and first of all you have to change your unit system to millimeters. You can do this here, so just check millimeter, or you can do that in options, document properties, units, and here you can also do that. Of course, you can do that before starting exam to change this and save document like a template, like a part millimeters or assembly millimeters, and if you need that in the exam, you can just start that template. I also recommend to change material before starting modeling. So if you have material in this list, you can choose that here. Now we don't have that here, so go to edit material, steel, and find alloy steel. Apply and close. Now start sketch on top plane. I use S key shortcut on my keyboard. Now in this boss extrude we also need a draft of 20 degrees. And when you do a real exam, double check all dimensions. And at this moment, I want to show one thing. Now you can see we have to make 4 arms. And on the internet I found some interesting solutions that are not good. They are wrong, I can say. I want just to point that out. So let's first make one boss extrude more. And now let's go on making arms. So you can say it like this. I want to make middle plane extrusion. Okay, let's see. Just make a simple sketch like this. Place a few dimensions and exit sketch. Do a mid-plane extrusion. Make a circular pattern. We need 4 arms, so just confirm. And you can say now this part is finished. So just go to evaluate. If you don't see evaluate tab, you can go right click and check this. So evaluate, mass properties, and you see your mass. Now go to question, and we don't have right value to check. So you think we have a right mass, and you're wrong. Why? If you zoom in, you will see some extra material here. If you go to PDF document, you can see that we don't have this. We have arc and straight line, and again arc and straight line, and so on. Here we don't have this. Maybe it's easier to see if I make a new circle, this corrodial, this one, and here it is. Here is this extra material. And because of that extra material, you have a wrong mass. Now I will show you how to do that in the right way. You have to do that in 2 steps. Make sure this is coincident and place just a few dimensions. Start sketch on this face. And place a couple of dimensions. And now you can see a difference. We don't have extra material here. Now everything is right. You see from this side we have an arc and straight line. So just to do one more circular pattern. Make sure you have selected both features, both extrude and cut extrude. And now you are finished. So go to evaluate, mass properties, and now you have the right value. Just save this as a base. Click save and move on to the next question. In the second question, we have to create an assembly from this part, make a new coordinate system, and find the center of mass relative to this new coordinate system. So let's do that. Make assembly from part. OK. Make sure you work with millimeters. And because this base is open, you have just to click to confirm this. And make a new coordinate system. You can do that from assembly, reference geometry, coordinate system. Make sure you orient all axes in the right way. So if you don't see coordinate system like me now, you can go here, just check this, and now we see this coordinate system. And you can now go to evaluate mass properties and make sure that here is not a default coordinate system. Here you need to check this. You need this coordinate system 1 to show right value. If you have this default coordinate system, you'll see wrong values here. So here are right values. And if you check here, now you see that obviously C is the answer, but X and Y axis are okay, but ZX is wrong. Well, you can see this value of minus 87.42 and we have minus 86.96. Well, their value is not right. It's very logical. If you see this dimension here, we have our coordinate system on one arm, like here, and obviously not this arm, but this arm on the side, this extrusion. So here, obviously from here to this center is 87.04, like you see here. And obviously our center of mass is not here, but closer to our coordinate system. And it can't be this value greater than 87.04, and their answer is greater, 87.42. So obviously this is not correct. So you can be sure that this value is correct. Now move on third question. So we have 3a, and just make a simple part called arm, and they gave us a hint to create a reference point to make easier later mating, but in this case I think it's not necessary. So let's do that, and I will show why it's not necessary. So again, make sure you are with millimeters and you edit material, and now we have this alloy here, so just check here, and let's start our sketch. Just place a few dimensions. And you can see here, now I will exit sketch and do extrusion of 4 millimeters, but mid plane. And now we have our origin in the center of this hole in center of R. So origin is really centered in center of this part. And that's why we don't need that reference point. If you model this in a different way, so origin is not in the center, probably a good idea is to make a reference point. But now I will leave this just as arm and save and move on to our next question. Now we have just to make a new assembly and insert one part and find a mass of that assembly called pivot. Browse for a pivot and just confirm. Now only thing you have to do is find a mass, and here it is. You can move on to next question. Now adding two parts and to find the mass of the whole assembly. So let's do that. You can pin this because we have to insert two components. Just browse for arm slot because arm is still opened. And confirm. Place a couple of mates. And I really like to use this select other to post some mates because I think it's easier and it makes things faster. And now you will see why we need origin in center of R. We have to make that to plane of arm slot, and it is going to be top plane, and make this coincident. And you can see we can still move this, so we need one more mate origin with this, and it is going to be a distance mate with a distance of 40. Confirm this, go to evaluate, mass properties, and now you can see the right mass. Let's move on. Just save this as a pivot. Now we have to add this pivot subassembly to our main assembly and to find center of mass. So let's do that. You can go with Control Tab between opened documents. So choose this assembly and we should save this. For example, CSWP assembly. And insert this pivot. Place a few mates. And now we have to find center of mass, and you can see this here. So make sure here is a coordinate system 1. Check here, so that's a B, and again this z-axis is wrong, but the same reason as in second question, so this is okay, and you can move on to next question. And here we have a collision detection. We have to determine this angle here, and let's see how to do this. So first of all, we have to suppress this parallel mate. So we can freely rotate this and go to assembly, move component, rotate component, and instead of standard drag, check collision detection. Make sure you stop at collision, and you can highlight faces. So it was already colliding, so just it's easier to position in non position, so like this. Again, collision detection, stop at collision, and now it's stopped and highlighted faces. Just confirm that and don't rotate components. Now we have to find this angle here, and I want to point out one thing. Of course you have to use measure tool, evaluate measure. I like to use M on my keyboard for measure. If you check these two faces, you can see this angle. But if you do this, go to normal tool and just rotate. I do this with holding out key and pressing arrow keys. If you go to this view, select measure and check these two edges, you can see this. This is a wrong angle because you choose edges. You chose edges, and that's a mistake. You have to be sure that you have a right angle. So instead of choosing edges, you can do this. You can make a new sketch, not this, and convert those edges in this sketch, and it will project those edges in the same plane, and now you can see a right angle. So we don't need this sketch, you can discard this, and make sure you measure the right angle. It's really important. So we can move on to next question. Here we have to add just one more part and find the center of mass. And first of all, unsuppress this mate. We need one concentric mate. One parallel. and we need one width mate. So you can find width mate not in standard mates but in advanced mates, and we don't need this space. So width mate, and everything is fully defined. So go to mass properties and find a center of mass. That's all from this question. Move on. Now we have to add one more subassembly called dumper, and we have to make dumper a flexible subassembly. So let's do that. We need to make this as flexible because of mates. You will see that in a moment. So first you have to make this flexible, and you can do that from component properties and solve as flexible, or you can do that with this icon here that say make subassembly flexible. And now you can see that icon next to name has changed, so it indicates that this subassembly is flexible, and that means that you can move this piston or housing relative to each other, and that's important for placing some mates. And if this subassembly wasn't flexible, it wouldn't be possible to place both concentric mates. So that's why we need flexible subassembly, and we need one more width mate, again advanced mates. And now you can find center of mass, so just rebuild this document. And here is our center of mass. In the 9th question, we have to use interference detection to determine collisions between the parts. And the only box that should be checked in the interference detection options is make interfering parts transparent. So let's see how to do this. First of all, we have to change, you can see we have to change this distance mate. So go to pivot and its mates. So edit feature. Make this 10 millimeters, confirm, close or exit edit assembly mode, and just rebuild, and everything is fine now. Go to evaluate interference detection, make sure only make interfering parts transparent is checked, and say calculate. If you check this component view, you will get answer on your question. So now you can just read arm slot, arm, housing and pivot, are answers to this question, and just check that here. So we can close this and move to the last question. Here we have to replace components, and we have to obviously delete some mates like parallel mate, and we have to place a distance mate here, and of course we have to find center of mass of the assembly. Let's see how to do this. First of all, you can collapse your feature tree with Shift C, and let's replace this space. So if you right click, and if you see don't see here replace components, go to these double arrows and find replace components. Replace this base with, and then browse phase B. So make sure that reattach mates is checked, and it shows some errors, but that's okay. That we need to remake some things and to fix this coordinate system. You can see here helping picture, and it shows previous base, and highlight faces that we need to find on our new base. And here you can see we miss 3 faces. So let's start with this first. So you can see it applied concentric mate, but you have to flip mate alignment like this. And with this arrow you can move on. Now you can see this face is checked, correct. We need now this face, and it's here. Move on, and this face, this little face is here for parallel mate, and everything is correct. So we can confirm this. And now just to fix our coordinate system, and now you can see everything is okay. We can move on other editing things. So just in bracket you should suppress or delete this parallel mate, and in pivot we don't need this distance mate. So just go to edit assembly and delete mate, exit editing mode, and make this pivot flexible like you have done with damper. And now you can see we can freely move this subassembly. And now we need just a few mates, and we just need angle mate, not coincident. Angle of 70 degrees, and not like this, but like this. You can play with flip dimension or make alignment to get what you need. Now everything is in place. Just one more mate, and it is going to be a distance mate, and I see that it's going to be easier if we use section view like this, because now we can see these faces that we need for mate, this face and this face. Okay. And yeah, you can't do that from top level assembly. You have to go to edit assembly mode, and again we don't need coincidence mate but distance mate. Make this confirm and exit editing mode and exit section view. And now you can see, so Shift C to collapse 3, and everything is in place, so we can find our last center of mass from this exam, and here it is. So you can see that it's not too hard, but you have to be familiar with commands and features that we mentioned in this tutorial, and you have to be sure that you double check all dimensions and not to make mistakes like in this first part, if you remember. And I just to say have a luck and thanks for watching.